Many students think voltage, current, EMF, and resistance are all the same, but once you understand this one idea, electricity, IGCSE electricity will become easy forever. So now, first, what is electricity? Okay, what is electricity? Electricity is just energy flowing through charges. So electricity is what? Energy flowing through charges. Then, before going to voltage, we have to know what is the difference between EMF and potential difference. So let's see that. EMF, we say electromotive force, which is energy given to the each coulomb of the charge by the battery. Energy given to each coulomb of charge by the battery. If the battery is supplying the energy, we call that voltage as EMF. And this is the reason the current is flowing. Okay, this is the reason the current is flowing in the circuit. We can think of an analogy. Battery is like a water pump and EMF is strength of that pump. Greater the strength, greater the flow of water. Okay, so EMF is the voltage of the source when no current flows. Also we can say EMF is the voltage of the source when no current flows. Okay, when there is no current, what is the voltage of the source? That we call it as EMF. It could be voltage of your battery, it could be your voltage of your power source. Next we have potential difference. Okay, potential difference. So potential difference is difference between the potential across 2 points. For example, if I have a circuit, okay, if I have a lamp and then I have a resistor, okay, and this voltage, let's say it is 9 volt, okay, so this is my EMF, okay, this is my EMF, and the potential difference would be what is the voltage drop here and what is the voltage drop here. Okay, let's take this is 1 and 2. Voltage drop across 1 and voltage drop across 2, or voltage of 1 and voltage of 2, that will be equal to 9 volt. That will be equal to 9 volt. So potential difference is energy used, okay, when the charges are flowing. Okay, or we can say energy used per unit charge. Energy used per unit charge. Okay, and if you see the SI unit of EMF, okay, it will be volts. Okay, or we can simply say capital V. If you see the SI unit of potential difference, this is also volts. Okay, so here it is energy used per unit charge, or it is like if a current passes through a component, bulb or a resistor, how much energy used. Okay, so we can say that potential difference, or we can say PD, potential difference, is the voltage across a component when current flows. It is voltage across a component when current flows. And you also know that PD, potential difference, okay, is always less than EMF. Okay, or it will be lesser than or equal to EMF if there is no energy loss. Lesser than or equal to EMF if there is no energy loss. If there is no energy loss. Okay. Next comes the current. Okay, next comes the current. Current. We denote current with I, and the unit for current, SI unit for current is ampere. So we can say capital A for that. Okay. Current is rate of flow of charges. Rate of flow of charges. Okay, greater the flow of charges with respect to time, greater the current. So the formula for current will be Q over T, flow of charges per time. Okay, so if the charges are flowing in less time, then we can say higher current. If the charges are flowing, okay, less in the given time, then we can say that the current is less. Current is less. Okay, and the formula for potential difference will be work done, okay, on charge, work done on charge. So the unit for this one will be joules per coulomb, joules per coulomb, or volts. Okay, joules per coulomb, or we can say volts for that. Yes. Next is resistance. Next is resistance. So resistance is just opposition of flow of charges, or opposition to the current. Okay, if something is opposes the flow of charges, we can call it as resistance. So resistance is simply opposition, or impedance also we can say, opposition to flow of charges. Okay, so this opposition comes when electrons, okay, are colliding with the atoms. Okay, when there is collision between the electrons, or obstacles when the electrons are moving, then we can say that there is resistance. Okay, it is not very easy to make the flow of electrons. Okay, so the formula for this one, R is equal to V over I from Ohm's law. Ohm's law is a law which connects resistance, voltage and current. So we can say V is equals to IR, or I is equals to V by R, or R is equals to V by I. In any form we can write. Okay, when we have say voltage and resistance, we can find the current. When we have current and resistance, we can find voltage. For example, let's take, we have a battery. Okay, this battery is 9 volts, and there is one lamp. Okay, and there is a switch. Now assume that if the switch is closed, okay, if the switch is closed, the resistance of the bulb is say 4.5 ohms. What is the current flowing? So I will simply use I is equals to V over R. V is 9 volts and my R is 4.5 ohms. So that will be giving me 2 amps. So 2 amps of current is flowing here. 2 amps of current is flowing. Like let's say that this 2 amps of current is going for only 2 seconds. Okay, so what is the flow of charge in 2 seconds, or how much amount of charge, okay, it is flowing? Then I will use Q is equals to IT, because I said I is equals to Q by T. Q is equals to IT, so I will be 2 amps and T will be 2 seconds. So 2 into 2 is 4 coulombs, because amps is coulombs per second. So coulombs per second into second, 1 second and the other second will be cancelling out, and finally we get 4 coulombs. Also, you must know what is charge of an electron, which is 1.6 into 10 power minus 19 coulombs. So if I say how many number of electrons are flowing in this one, then there is one more formula which we have to remember. Q is equals to NE. So N is equals to Q over E. Okay, so Q is 4 and my E is 1.6 into 10 power minus 19 C. Okay, so if I use the calculator, I'll be getting 2.5 into 10 power 19, 2.5 into 10 power 19 number of electrons. or we can say close to 3 into 10 power 19 electrons. According to the quantization of charge, the n can be a whole number. N can be a whole number. So these things you have to remember, okay, when it comes to voltage, current and resistance. Okay, so for a ohmic resistance, for ohmic resistance or resistors, then R is always constant. R is always constant. So we can say that R is equals to V by I. So V and I are proportionally increasing or decreasing. So if you see the graph for a perfectly ohmic resistor, then it will be a straight line. It will be a straight line. We can say this is V and this is I. So if I want to take the gradient of this one, okay, I'll be getting I over V, that is equal to 1 over resistance, or reciprocal of that gradient will give me R. So 1 over G, that is equal to R. So if the y-axis and x-axis is changing, suppose V is in the y-axis and I is in the x-axis, then directly gradient will be equal to the resistance. And this type of straight line we'll be getting for a fixed or a constant resistance. Fixed or a constant resistance. Okay, so this is basic video about electricity. So if you like this video, just follow me, like and subscribe, and I'll be posting you for you more and more videos in upcoming days.